All right, so the point of problem 4 on set theory 1 is to get you to work through the necessary details to understand a proof that 6z is a subset of 3z. So let's prove this now. All right, so to prove this, what we have to realize is that the definition of subset is really a conditional statement. So let's tell the reader that's what we're going to do. Okay, we prove x in 6z implies x is in 3z. So suppose, or assume, I guess assume maybe makes more sense. Let's say assume. Assume x is in 6z. Now remember why it makes sense for us to assume this. There's two possibilities, right? Either x is in 6z or x is not in 6z. If x is not in 6z, then this is false, and the overall statement is true. So we may as well assume this one, because if we assume this, then we're done. So assume x is in 6z. So what does that mean? So x equals 6k for some integer k, for some integer k. Now, because we have set theory and this symbol, we can simplify this greatly. We can write this now as for some k in z. So we don't have to write this word out all the time. And my arm is getting tired. Now, as we're doing a proof, we might off to the side say, okay, what do we want to show? What do we want to prove? We want to prove that x is in 3z, right? Well, what does that mean? That means that x is equal to 3 times some integer. Well, let's see. We have that x is equal to 6k, right? And 6 is equal to 3 times 2. So x is equal to 3 times 2k. Now remember the quantification, or the defining of the variables. Here we defined where k lived. K is an integer, right? We can only say that x is in 3z if x is equal to 3 times some integer. And since k is an integer and 2 is an integer, 2k is an integer. That's a really important part. So since k is in z and 2 is in z, comma, so is 2k. So x is in 3z. And that completes the proof. We showed that assuming x was in 6z, that x was in 3z. That finishes the proof.